Okay, so here you've got a question which basically has a few dots and a line. And what you're trying to do is find some sort of relationship between these dots and this line. And we'll probably need to have a think about what sort of theory we might be useful for. And so have a think about that as we read this question. But the difficulty with questions like this is not so much the math itself, but it's coming up with the way to answer those questions, which is the abstract type of question. So let's see what the question says. And you have a figure. You have 9 points. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 5 of which lie on the line L. 1, 2, 3, 4, 5 on this line L. No other set of 3 of these points are collinear. So firstly, you have to understand what that means, which collinear means on the same line. So what they're basically saying is, okay, we have 9 points, 5 of which are on line L, but with any other 2 points, for example, those 2, or these 2, or we might say like these 2, they don't go through any other third point. Or I could try a few other things like this one. They never ever hit another point. Okay. And you might want to think about why that's important and why they're telling you that as we look at the questions. Question 1 says, how many sets of 3 points can be chosen from the 5 points lying on line L? That should be pretty simple. You've got 5 points on line L, and you want to choose 3 points from that. Now, it doesn't say order, it says a set of 3 points. So if I label this A, B, C, D, E, then basically if you pick A, B, C, it's the same as picking A, C, B. It's the same as picking C, A, B. They're all the same 3 points. So the set of 3 points chosen from 5 points lying on L should be quite clear to you that order doesn't matter. And so this is a combination, not a permutation. 5 things, you're choosing 3. So colloquially, 5C3 is what we'd say. And you can use your calculator if you like to quickly get that as a number, which is just 10 ways. So there are 10 sets of 3 points when we're picking them out of those 5 points there. But much more difficult then is the second question, where they're asking how many different triangles can be formed from the 9 points as vertices, which means you have 9 points and you want to see how many triangles you can draw. Now, the question is not difficult as long as you approach it the right way. And so you might want to consider what that way is. Remember, you're trying to draw a triangle. Now, when we're trying to draw a triangle, it probably makes sense to understand that, well, you're really just drawing lines between 3 points. So as long as you're drawing, well, you have 3 points, you have a triangle, really, maybe, sort of. Now, here you have 9 points. So you might think, well, 9 points, 9 different points. If I've picked 3 points from those 9 points, then I have a triangle, right? So probably we might see 9C3, potentially. But unfortunately, that's not the right answer, right? You do have 9 different points, okay? And if we have, say, a 4th point, then indeed, we actually have a few triangles here, because if we have a 4th point, and let's call this W, then we definitely have a few different triangles we could draw. We could draw WXZ. We could draw WXY, like so, the green one. Or we could draw, so we've got WXY, WYZ, we've got WZX, as we've already drawn. And so you can see there's a few different triangles. 1, 2, 3, 4 triangles, also WYZ as well, right? And that seems to match what we're saying. We've got 4 points, and we're going to draw, we get 4C3, which is 4 triangles, as expected. But what you need to consider, and maybe as a hint, is when you pick 3 points and you don't get a triangle. And when you think about that, you might also think about the fact that this is part 2 and you have a part 1. So if you have 3 points, like A, B, C, and you join them up, well, that doesn't look like much of a triangle, does it? It kind of is just a straight line. Or alternatively, we could pick another 3 points. So for example, we pick C, D, and E. So C and D join up, D and E join up, and C and E join up. Again, not really much of a triangle. So what we're really saying here is to get a triangle, you need to pick 3 points, which are different, of course. You can't pick the same point. But they also can't be collinear. So when we did 9C3, we ignored the possibility of being collinear. And that means we're going to potentially pick situations where you won't form a triangle. So now you need to pick 3 points and they can't be collinear. And then it's a bit cumbersome to go, okay, what about if I picked 1 on the line, or if I picked 2 on the line, and I definitely don't want to pick 3 on the line. So you could do it that way. But the nice, easy way to do it is simply just go all choices, which is 9C3. That's too many though. And take away the choices that we don't want, which is only pick from the collinear ones, which is minus 5C3. That will be the easy way to do it. And once you take away that subtraction, you'll get 74. Of course, as we mentioned, you could have split it into cases. You could have split it as cases into, okay, no collinear picked, none from A to E, 1 from A to E, and 2 from A to E. And you could have done it that way, but it's a lot longer and it will just, it's not as quick as just using, and you're kind of ignoring part 1. Part 1 is there to help you. So remember, when you're doing questions, pay attention to earlier parts, look at the hints, and then, yeah, try to see the best way to do it. And that's how we do this question.